Stream SaaSification is all about delivering these really intense apps and desktops in a SaaS-type model, in a cloud-type model. So there's a friend and partner of ours that is way more qualified to talk about these kinds of apps, these kinds of users, and this kind of environment, this technical environment that I'd like to introduce you to. And that's our friend and partner, NVIDIA, Jen-Hsun Wang, who's CEO and co-founder of NVIDIA. Please welcome Jensen.
Hey, Jensen, good to see you. Great to see you. Great to see you. Well, first of all, nice shirt.
Thank you.
It's great to be here. You look very sassy today.
Thank you. I'm feeling pretty sassified so far. So, you know, this partnership and friendship goes back, I think, to about 2006.
Yeah, our two companies have been working together on a very challenging problem for coming up on 10 years. It started, as you recall, on building one of the world's largest mechanical equipment, the Boeing 787.
Yeah.
And the challenge that they wanted us to undertake was to design the entire plane in digital.
Yep.
And if you want to design the entire plane in digital, but it's being built all over the world, engineers all over the world, suppliers all over the world, and it doesn't get assembled until the very end, they had to work with very, very large data. Calling it large data, you know, calling that large data is really an understatement. And to make it possible for everybody to collaborate at the same time. So it was quite a challenge. And so our two companies started working together right about that time.
Yeah, and it led to some amazing innovations on HDX and at NVIDIA in your GPU chip.
Yeah, you know, we forget that now, but back in the good old days, when we started working on Boeing, we actually failed. The first project was too difficult.
Yep.
And we learned that it was incredibly hard to get graphics to be in the cloud, get graphics to be in the server, and to make it so that it's interactive, supported all of the complicated applications that they used in order to design the Boeing 787.
Yep.
And but we learned a great deal. We learned right on the ground the challenge of SaaSifying, of extreme SaaSifying. Mm-hmm. And so we started working on a roadmap that led us to today, and we have some pretty amazing things we want to show you guys today.
Let's do it.
Okay.
Let's get Brad out here to help.
Now you can see my iPad, the same one in fact. We're connected in here to a cloud service, and it is connected into receiver, you can see, and I've got Adobe Photoshop here, and that's what I'm going to open up. So let me go ahead and click on that. It's running on a system up in the cloud that's got just monster HP CPU, tons of memory, solid state drives, you know, NVIDIA K2 cards, and I can bring it up here and show you the response time. So again, iPad, the new receiver with super HDX capabilities connected in. I'm going to go into the cloud into here and file and go ahead and open. And in this, I'm going to grab a photograph that exists already. Let's go ahead and go back here and go into open. This photograph here, I don't know if you've seen this before, but it's models in a walkway, okay? We can start with them. We're going to make some changes. So I'm going to pull up some filters here. One is called Liquify. So Liquify is going to use the GPU on the back end pretty significantly. You can kind of grab and stretch. You know,
that's a big improvement, Brett.
Yeah.
Yeah, you're doing good. You have a long career in this kind of work.
Well, hey, by the way, I can open that window up much larger. Check this out. I can move it right over here, let the sun shine in, right? Liquify. So obviously there's mass manipulation of pixels here, and that's great. Okay, so tell you what, let me go into here, and we'll grab that filter again. So Liquify, and just make a few stretches, and we're going to save this work, and we'll hit OK. So the next filter that I'm going to put in here is called Oil Paint. So we bring up Oil Paint, so you can see it just adds that effect to it instantly. And if I grab the scale bar and rip it back and forth here, again, massive recomputation of pixels and redesign, and I can grab the one that I want, hit that, and hit OK also. I can even go into 3D and add a 3D effect here. So with the 3D effects, you can grab the corner and rotate this around, so you can see kind of behind it and rotate. And the response time on here is just unbelievably amazing. If I move my finger around here, right? Yeah.
Now you know what's really special about the work that we've done here is that Photoshop was completely unchanged. The entire application was already there. It uses OpenGL, uses all of Windows, of course, but it also uses a capability called GPGPU. It uses GPU in a general purpose computing, parallel computing way that we invented about 10 years ago. And all of these capability just made possible just like that.
Yeah.
And all because of this architecture that we worked on together. And what you were doing just now, which I loved the moment I saw it, using your finger to control Windows.
Yeah, right. And who would have thought? So iPad connected that far away. Great user experience. So sassification. It kills me. It's like I've been assassinated.
Oh.
Yeah, almost, right? But SAS is not enough. We can go beyond SAS, right?
Yeah.
Where no one gets killed.
Yeah, so sassifying apps is about taking these extreme apps and moving them to the cloud. You know, whether you're an enterprise or you're an ISV that wants to take advantage of your app, but in a cloud service world and mobile. So the other problem is there are tons of people that use workstations, these big giant workstations, right? And they're not going anywhere with those workstations. So the question is, how do you sassify, that kind of environment?
Yeah.
That's even harder.
And in fact, this is the first part of the demo we're about to show you is exactly the learnings from our first project, which was codenamed Pictor, and was the Boeing project. Mm-hmm. And what we're about to show you is the work that resulted directly from that early experience. The engineers needed to have access to their entire desktop. And their engineers could be anywhere around the United States. Some of the engineers could be far away. And what they discovered was that if you want the entire Boeing 787 and all of its construction and all of its design and all of its materials all inside digital, it's impossible at that point to transfer the database to each one of the design centers. It had to be centralized. Yeah. It was actually easier to transport the pixels, the rendered pixels, anywhere around the world. The challenge that we had at the time is we just didn't have the technology that was possible to render the beautiful imagery and the complicated imagery, support all their applications, compress it and stream it to engineers around the world. And now, well, let's show it to them.
Good. Hey, the first one we're going to look at, you see the screen here. This is 5 different desktops running. So on the back end, on high-speed servers with graphics cards in them, right? The grid K2s. The first one we're going to look at in the bottom left-hand corner.
So let me make sure that everybody understands it. And it's all working so well that it all sometimes just you lose track of what the technology kind of disappeared.
Right.
You're looking at a Macintosh. This is the Power Mac, the MacBook, of course. There are 5 workstations in 5 different windows, all running concurrently on this Mac.
Which is not an uncommon thing for an engineer to have multiple workstations around.
That's right. And usually, in fact, the video that you guys saw, those pack stations were all driven by NVIDIA graphics cards. Mm-hmm. And what you see in those cases, those medical imaging cases, that they'll have workstations with multiple graphics cards, each one of them driving a different display. Mm-hmm. That workstation is sitting right underneath the foot of that particular doctor, of course. Right? So this particular case, you have the MacBook Pro here, and you have 5 windows open, but you could have more windows open if you like, and each one of those windows could be running a completely different workstation, basically.
Exactly.
Yep.
And of course, all these applications are high-end Windows applications, but we're here on our Mac, running it from here. Now, the 2 applications, the desktops on the bottom, represent applications that are running super high speed with dedicated GPUs associated with them, and we're going to look at the 2 bottom ones first. The one on the bottom left-hand corner is right here, and this is RTT Delta. And I'm going to go ahead and kick this into animation here.
So let me tell you about this application real quick. This is the RTT's Delta Gen. RTT is the world leader in design visualization. Almost every car company in the world uses them to visualize the design, to see the various styling choices, and run their power walls with it. In order to do this, this is currently running in real time. It's being rendered on a workstation off on the network here. And in order to make it look so realistic, the geometry of the car, of course, has to be incredibly high fidelity. But each one of the pixels are rendered with true material behaviors. And so the paint, the car paint, is actually true car paint. It uses a technology called BDRF, or bidirectional reflectance distribution function. Basically, it allows you to simulate how light bounces off of different materials. In this case, it would be car paint. It looks like car paint, reflects like car paint, shadows like car paint, and everything is being rendered in real time.
Beautiful. I want one.
You know, Mark, I wouldn't be surprised if you actually have one already.
Yes. Okay, so the next is a Adobe Premiere. So we have a video running here of a motorcycle guy cruising across, and we can go ahead here and brush through the blurriness back and forth in real time. So far left is super crisp, far right is blur, back and forth.
Now you guys can't tell from this because of the display, but the content is 4K. The content is full 4K, and we're sitting here, you know, making manipulations to it. You could be compositing it with 3D. You could change the color tone. One of the last passes of making a movie is to bring emotion to it, the sensibility, the emotion of the film. You could change the tone of the entire film and get it to be color graded all to the same color tone. And that process is extremely time consuming. And look, you're doing it completely in real time.
Real time.
Yeah. Not only are you a wonderful photographer,
So,
cinematographer.
so those are desktops. It's sort of like DASification.
Well, those two applications are typically run on extreme workstations.
Yep.
The most powerful workstations that you can buy, and the most complex GPUs that we make. In fact, the application that's on the left, the lower left, the RTT Delta doesn't even run on a Mac. I mean, for a second there, we all kind of forgot the fact that that application doesn't actually run on a Mac.
Right.
It's not running on the Mac.
Wow.
Right? It's like, this is like Netflix that we're controlling. You know, it's fantastic. And so that was extreme DASification and you're looking at two workstations that you're accessing. And Brad, in fact, you could close the windows. You go into open one of them, and close the app, right? Can't you close the app? Mm-hmm. Look, you're on a desktop. You're a desktop in a desktop. Extreme DASification.
There it is.
That was
That's it.
Okay. So now you have a remote desktop, and you can run not almost everything. You can run literally everything. So any application you can find, it could be a video game, it could be movies, it could be iTunes, it could be RTT Delta Gen. Everything just runs. Yeah. But one of the challenges that we had was to figure out how to, now that you've put this in the cloud, now that you put it in the data center, we wanted to be able to share it among a lot of different people. Yeah. And that was the ultimate challenge that your team and my team have been working on now for coming up to probably close to 5 years. Yeah. And it starts, the technology is called virtualization. Virtualization is something that everybody here in the audience surely know. However, the concept of virtualizing a GPU had never been done before. The GPU, as a processor, is very, very high throughput, whereas a CPU has one thread, which is one program that it runs at one time. A GPU has thousands of threads. We could run up to 15,000 threads inside one of our GPUs. So 15,000 little programs are running in our GPU. How would you context switch that? Right. How would you virtualize that? Yeah. And so we went off to create a new generation of GPUs called Kepler. We put virtualization hardware right into the GPU. So now every single program runs through an MMU that goes through our GPU. And as a result, we've been able to virtualize the processor itself. That was just the first part of the job. The second part of it, of course, is to integrate it with your software so that we can make it possible for anybody to be able to access a virtualized remote workstation for the very, very first time. And so what Brad has now on the desktop, the next three applications on top, are virtualized applications running on top of a virtual GPU running inside a virtual workstation. This is virtualization to the extreme. Now, the amazing thing is some of the applications you're seeing here, the first one you saw was AutoCAD. AutoCAD is really the de facto standard for high volume design, and it's the Swiss Army knife of CAD applications. People use it for all kinds of stuff. They use it to build dog houses all the way down to, churches and Capitol buildings. And so it is used by millions and millions of people around the world. Another application here on the left, this is Siemens Teamcenter. It's PLM, if you guys are familiar with that. And basically PLM is a software platform that spans design all the way to manufacturing. And it integrates every part of the design and manufacturing process. It is the ERP of design. And millions of people use this software package here. This is Siemens Teamcenter, but there's also PTC's Windchill, which NVIDIA uses, and Dassault has their system, and Autodesk has their system. This is used by millions and millions of people around the world. So if you have engineers, you have manufacturing, you have operations, you have quality assurance, you have repair, you have shipping, logistics, and if you have suppliers, you're working with them on this particular application. This is now for the first time made possible on a remote desktop like this.
So through the vGPU, you get sharing, and which is, gives you great economics around creating this kind of environment for, an engineering team to not only, work in the design center, but enable them to go mobile, share the designs, et cetera, with third parties, and really unlock and unleash this app that is traditionally locked to a workstation.
Exactly. It's now centralized. It's virtualized, of course. It's remoted, therefore it's mobile. And it also works on any platform. This is a Mac. It works on anything that has a Citrix receiver. Yeah. And so it works on an iPad. It works on an Android device. It can work on anything with a display with a Citrix receiver, so anywhere.
Easy. How about this Windows
machine? We got
one
more example of that, and that's this Windows machine over here. Now, what is different about this is we have a Leap Motion connected up to it, right? So with this, Leap Motion allows you to take your hands off the trackpad and the mouse, and you can just gesture to it. So this is some new technology. In fact, if I open up the visualizer...
one of the things we learned working with Boeing and et cetera is that engineers and designers, that sort of the fluidity of the experience really matters. Because when the software gets in the way, creativity goes down. When the software's out of the way and fluidity goes up, they're more creative. So these kinds of input devices are really powerful for that kind of use case.
So we can check finger tracking on this application here, but what's really interesting, if we run Google Earth on the back end on the GPU, it's going to come up. And we're going to control it entirely by hand gesture here. So
Brad, first of all, I think what you're showing here, the first time you showed this to me, I was pretty excited. The application itself is virtual.
Yeah.
It's on a server. But now the input gesture recognition device is also going to be processed remotely, and it's going to be sent remotely to the server, and it's going to interact with a 3D environment and send the images back to us. Right? Exactly. So interactivity is very high, and the latency is very, very low.
Super fast, so we got to see it. You want to fly?
No, I'll let you fly.
All right, yeah, okay. Put your hand.
Wow.
Right, and I can turn it sideways here so you can probably see it. So it's just a little stick on the side here. And you put your hand over the gestures and you can control, so you can zoom down into the earth and turn left, spin around, right? And then turn right, turn left. Come on up into space, back down. Look at the speed of that.
So if there's any question about the interactivity of HDX and our GPU.
Any.
Yeah.
Right, exactly.
It's pretty much gone at
Sure you don't want to fly?
There you go.
Good. All right.
So, thank you.
Okay.
You. So
now, we didn't get a chance to go through the slides.
Yeah. So
what we showed you guys is the work that we've been working together for quite some time, and today we're announcing that the NVIDIA GRID virtual GPU, called vGPU, has been integrated into the Citrix XenDesktop 7. And you can now enjoy extreme SaaSification, extreme DASification of applications of almost any kind. Any Windows application, whether it's OpenGL or DirectX, uses GPGPU, any application that you know of, whether it's workstations or medical imaging or architectural design, now just works. And it works in a virtual environment. It works in a virtual workstation, and now it's running on a virtual GPU. That endeavor has taken us almost 10 years. It has been a great pleasure working with you guys, and now tens of millions of people around the world can benefit from mobilization. They can now be able to do their work on any platform, anywhere they like.
We're just getting started.
All right.
Thank you, Jensen.
All right.
Congrats.